Hey, there you Joe. Hey, today we're going to look at modeling an existing exhaust system. A user wanted me to model this in the software. They kind of didn't know how to do that. This is what they had. They had some 8-inch round ducts, which were 70 feet in length, and they had 6 elbows in those. They had some 10-inch round ductwork that was 100 feet in length and a couple elbows, and that had duct liner in it. This ductwork was round, and they weren't getting flow from their grills there. And so obviously they didn't have a big enough fan or motor, but modeling that existing system, they should have had around 1.63 inches of static pressure. So you see the velocities are very high on the ductwork, as well as the static pressure, 0.69, 0.39. Okay, if you would model this in the software, it's kind of our default velocities and static pressure. The software comes up with a system of 0.68. So you have a 1.5 horsepower motor in lieu of the 5 horsepower. So obviously the ductwork, the software selected larger ductwork, 14 by 14, 12-inch round, instead of the 10 by 10 of the 8-inch round. And it did that because we were using more standard velocities and static pressure. But a lot of times exhaust systems get put in, the space is constricted, they have to do smaller ductwork, more elbows, and run them all through the building. Obviously, it's kind of one of the last things usually put in. So sometimes if you don't model those, they can get out of hand, and the fans aren't going to work with the right proper airflow. So let's just model this quickly so you can see how to model something existing. I'm going to put a space on the screen, come in, grab an exhaust register grill. As soon as I put that in there, you'll notice my space gets larger. Now I can highlight that and make that space a bigger space. I'm going to come in here, copy that, put another one over there, go grab me a fan, Twin City. Okay, come down here, we'll get a forward curve belt, and then just hook that system up. So I need to come in, add exhaust. We can do that to a space or the exhaust fan. And so right here, we're going to add 1,000 CFM. And now I need to come in. I'm going to select this duct as well as this duct and go in under the standards of ductwork under shapes. And we're going to make that exhaust down here a round. Okay, and why I have those two selected, we're going to come up here to key data. And I'm going to say, well, they're both 70 feet long, okay, and they're 8-inch existing ductwork. And why I've got it, the two highlighted there, ducts 8 and 9, I'm going to come in fittings. And instead of doing a fitting factor, typically I'm just going to come in here and say, I'd like to do some elbows, and I want 6 elbows. That's the ASHRAE ductwork database in there. And now hit apply. You see the duct kind of changed to a different look there, kind of a round duct look. Now if I come in there and kind of show static pressure, length, it'll highlight on that. So now you'll see this duct needs to be changed to 10 by 10 to model the existing. It should have been a 10 by 18 if they would have used standard velocities and sizes. 10 by 10, the length is 100, and it had 2 fittings in there of elbows. So put 2 in there. Now you see we're 1.49 inches. We're kind of close there. There's probably something that's not different. This was 0.69. So we're missing something else in the modeling of that. We'll go back and just look what I hit. I did 10 by 10, 100 feet. Let's see. Oh, the duct. We need to come in here. On the duct type, they said lining, right? Material. We default to galvanized. When you add lining in system, it does increase your static pressure. So there's the duct liner. Let's apply that. And now you'll see I added quite a bit of static when the velocity is that high in a system. So there we go, modeling that existing system that was kind of built on that project. Like you see, a lot of times exhaust systems are put in last. They add more elbows, make ducts smaller, and a lot of times the fans and the airflow suffer. So I hope this has been helpful in um, in modeling the exhaust existing systems. Hey, thanks for watching.